the minimal cover, or we want to find the fourth, that is application of functional dependencies, is to find the minimal set of functional dependencies. Minimal set of functional dependencies. What do I mean when I'm saying minimal set of functional dependencies? Is that if there are some f is a set of given set of functional dependencies, then we want to find a set of functional dependencies with G, and this G should be a minimal set, which also covers F. G should be a minimal set which also covers F. Okay, so we can write it down here. A minimal cover for a set of functional dependencies, F is a set of functional dependencies G is a set of functional dependencies G that satisfies the property that every dependency in F is in G, or you can say is in G closure, then G is called minimal set. Okay, so this is a procedure of finding the minimal set. So let us write the procedure to find minimal set. Okay, so the step 1, this is we'll be having different steps. So step 1, put the functional dependencies in the standard form. Put the functional dependencies in standard form. So what is the standard form? If there's some functional dependency which is given like A determines BC, then you can convert this given functional dependency to A determines B and A determines C. So if you have any functional dependency like this, first of all put the functional dependency in the standard form. So second step is remove the redundant functional dependencies. Remove the redundant functional dependencies. Like if you have the functional dependency A determines B, B determines C, and A determines C. Now in this complete set of functional dependency, this A determines C is redundant. Why? Because it is already transitive. That means we already know that A determines B and B determines C. So obviously A can determine C. So there's no point of writing this functional dependency. So we can just remove it because it is redundant. So we already know that A determines B and B determines C. That is enough to say that A determines C. And the third step is minimize the left hand side of each functional dependency. That means if you have functional dependency like AB can determine C, so here in the left hand side we have AB. So this you try to minimize it. How can you minimize it? Step 1, you can write it like this. If A can be deleted if B plus contains A. In the same way, B can be deleted if A plus contains B, right? So you can say if there was any removal of variables in step 3, then repeat the step 2. After that repeat step 3 and repeat this till there is no removal. Okay, so that we can get it will be minimal. So we'll get minimal. Okay, so you can note all these 3 steps down in your notebook, and let us try to apply these steps. Okay, so assuming that we have the functional dependencies like A can determine B and B can determine C, and A can determine C. So in this functional dependency, first of all you have to remove A determines C because it is redundant. There's no point of writing this. So the minimal set will be containing A can determine B and B can determine C, that we already know. Okay, and assuming that the next functional dependency which is given is like this: AB can determine C and A can determine B. Now here in this case, so what was the first step? Step 1 was put the functional dependencies in the standard form. So in the right hand side there is nothing where we have more than one functional dependencies, therefore all of them are already in the standard form. Second is remove the redundant functional dependencies. There is no redundant functional dependencies here. Step 3, if in the left hand side we have more than one attributes, now let's check if you can minimize it. Here we have more than one attribute. So first of all find A closure. Then A closure can contain A, B, and with the help of AB I can identify C. In the same way, find B closure. With the help of B closure I can only identify B itself. So you can say if A closure contains B, hence from these functional dependency I can remove B. Therefore the minimal set of functional dependency will be containing A can determine C and A can determine B. So this is representing the minimal set of functional dependency which is covering these functional dependencies. Okay, now let us take more examples. Assuming that we are having the following functional dependencies: F, A can determine C, AC can determine D, E can determine AD, and E can determine H. So we need to find what is a minimal set of functional dependency. So what is the step 1? Step 1 is write all these functional dependency in the standard form. So standard form will be A determines C, AC determines D, E determines A, so we are going to break this one, E determine D, and E determine H. So this is the step 1. Okay, after the step 1, do the step 2. Step 2, that means try to see if there's any redundant attribute or is there any redundant functional dependencies. Okay, so let us number them. This is 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. So if you compute A closure, see there's one more way of evaluating the step 2. So let us see, if you compute A closure, then let us see what are the attributes which you are using, because if these functional dependencies you are using to find A closure, then obviously they are used. So if you use A closure, you can see A can determine AC. With the help of AC you can determine D, that means second functional dependency is used. With the help of there's nothing, 3, 4 and 5 they are not used. Okay, so fine. Okay, let me do this, let me do it explain it another way. So is there anything which is redundant here? Redundant, like we have transitive functional dependency and so on. So is there any transitive functional dependency here? Okay, we need to identify that. So next, if we do AC determines D, this is the second functional dependency, AC determine D. So if you do AC closure, you can get A, C, D and nothing else. Okay, with the help of A closure you can do ACD. With the help of AC closure also you can do ACD. Okay, further from these you can see here C is redundant. We will be removing that in the step 3. But anyways, take the next functional dependency, that is E determines A. That means if you do E closure, you can get E, A, D, H. With the help of A I can get C. With the help of AC I can get D, which is already there. So here you see you have used all of them. Next, if I identify E drives H, if I take E closure, further I can do A, C, D, E. Okay, so I will not be able A, C, D, E and H, right? So I will be able to identify everything, right? So here you can see, if you delete the function dependency number 4, still E can determine D. Still E can determine D without even using this one, right? How? Because E can determine A can determine C, and AC can determine D. So even if you delete this one, there is a fourth one, still you will be able to identify D, so it is not required at all. Now in the step 3, so we are going to remove this one here. Now in the step 3, if you have AC drives D, you can clearly see AC drives D is there. If you took A closure, I can get ACD. The further C is not required here. So if you remove C here, so it can be written as A drives D. So if you remove this one, so what is the function dependencies you can get? You can see we have A drives C, A drives D. Why? Because in the step 3 we removed this C, then E drives A and E drives H. So with these functional dependency, you can see this is a minimal set which is representing the above set. It is a minimal set which is representing the above set. Okay, so this is how you can minimize the functional dependencies. Let me do one thing. Okay, fine. Let me take one more example, and that will be the last example here. So assuming that the functional dependencies they are given is A drives B, C drives B, D drives A, B, C, and AC drives D. So check the step 1. Step 1 is if there is a functional dependency, break all of them. So you can write after step 1 it will be A drives B, C drives B, D drives A, D drives B, and D drives C, and AC drives D. Now in the step 2 you can see, is there any transitive functional dependency which is occurring? Is there any transitive functional dependency which is occurring? Okay, so you can see A drives B, right? Or make it like this: D drives A, and fine. So D drives A is there, and if I do D drives B, and A also drives B, so you can see D drives A drives B, so obviously D drives B. This is already present, so it is transitive, so we do not require D drives B. We can remove it. We can remove D drives B. Okay, now is there anything else we can remove apart of this D drives B? So we know A drives B. Okay, right, so you can also do like this: D drives C, C drives B, therefore D drives B. This is also there. Okay, so we do not need this one. So this is step 2. We cannot remove anything else. So after step 2, the functional dependencies are like this: A drives B, C drives B, D drives A, D drives C, and AC drives D. Now let us apply the step 3. That means if you have a functional dependency here, try to find A closure. A closure will get you A, B, and you cannot get C from A closure, right? If you do C closure, that means you can get C, B, but you cannot get A here, therefore you cannot break this one. So after the step 3, let us see if you can remove it further. If you have, can you remove anything here? A drives B, C drives B, right? So A closure contain AB, right? C closure contain CD, but nothing else. But it is not containing A, therefore you cannot remove this one. Is there any transitive functional dependency which is occurring here? Transitive functional dependency which is occurring here. A drives B. Okay, fine. So right, so there is no transitive functional dependency, so this is the minimal set. Right? So you cannot minimize it any further. Okay, now let me